Okay, guys, we're back, and today we're going to start on Chapter 7, and the first section is called Ratios and Proportions. Why doesn't ratio rhyme with patio? Somebody explain that to me. So what are ratios? A ratio is a comparison of two quantities using division. The ratio of quantities, A and B, can be expressed as A to B with a colon in between. A over B is a fraction, where B does not equal 0. Ratios should always be expressed in simplest forms. You guys have been working with ratios since grammar school because fractions are ratios. When you convert a fraction into a decimal, you're doing ratio work. Insert awesome ratio example problems here. Okay. So a baseball player's batting average is the ratio of the number of base hits to the number of at-bats, not including walks. Minnesota Twins' Joe Mauer had the highest batting average in Major League Baseball in 2006. Yeah, that's when you guys were like 2. If he had 521 official at-bats and 181 hits, find his batting average. So they tell us what the ratio should be, which is number of at-bats, which would be again, uh, number of hits, 181. Let's see if we can get this to work properly, please. Over the number of at-bats. So we just take that and we take out the handy dandy calculator and we divide and we're going to round it. They round to 3 decimal places. So his batting average would be 0.347. The fourth place is a 4, so we're going to round it down, 0.347. In Logan's High School, there are 190 teachers and 2,650 students. What is the approximate student-teacher ratio at his school? Go ahead and hit pause here and try working this out on your own on a sheet of paper. Don't worry, I'll be here when you get back. So what'd you get for your final answer? Well, let's do it. So there were 190 teachers and 2,650 students. So they tell us that the ratio is student to teacher. So we need to make it student over teacher. Now, so you take your calculator, 2,650 divided by 190. Well, that comes out to approximately 13.95. Well, here's something kind of goofy. And when we work with this, we do have to do a little bit of common sense thinking. You can't have 0.95 of a student. So we would say our answer is we have to round up to the nearest whole number, right? Because we're dealing with people here. You don't have fractions of people. So we would say approximately 14, we could say it 14 to 1. Okay, and they do say here approximately right there too. Okay, extended ratios. Those are ratios which compare 3 or more values. So the expression A to B to C means the ratio of the first 2 values is A to B, the ratio of the second 2 values is B to C, and the ratio of first and last values is A to C. So we're going to do some more awesome ratio example problems here. So the ratio of the measures of the angles in a triangle is 3 to 4 to 5. Find the measures of the angles. Well, if the ratios are 3 to 4 to 5, that means that we have reduced that. So we know it's 3 times some number that was reducing it, plus 4 times some number that was reducing it, plus 5 times some number that was reducing it. And that's going to equal 180, right? So add this up, we get 12x equals 180. Divide each side by 12. Use your handy dandy calculator if you have to. You find out that x equals 15. So the actual angle measurements will go from small to large, would be 45, 60, 75, and that would be your final answer. In a triangle, the ratio of the measures of the sides is 2 to 2 to 3, and the perimeter is 392 inches. Find the length of the longest side of the triangle. So we're looking for the longest side. So, again, we're going to set this up as 2x plus 2x plus 3x. They should add up to 392. So we end up with 7x equals 392. 392 divided by 7 is 56. So x is equal to 56. Now they're looking for the longest side. So 3 times 56 is going to be our longest side. So the longest side is 168. Make sure you circle your answers on the quizzes so it's easy to find. Okay, so now what is a proportion? Basically, a proportion is when two ratios are equal. Okay, so in this proportion, A over B equals C over D, the numbers A and D are called the extremes of the proportion. The numbers B and C are called the means. And the reason they do that, and I'll write this over here, if we write these like this, so the extremes are on the outside, and the means are on the inside. So that's how they came up with that. Anyway, the product of the extremes and the product of the means are called cross products. So AD and BC are cross products. If you remember, you've done this before, you did some what we call cross multiply and divide. Okay, that's working with proportions. So you've been doing this for a while. This is nothing new. Excuse me. So in a proportion, the product of the extremes equals the product of the means. So if A over B equals C over D, when B can't equal 0 and D can't equal 0, because you can't have 0 in the denominator, then AD equals BC. Now the converse of this is that if you have a product, okay, so if AD equals BC, and B does not equal 0, and D does not equal 0, then A over B equals C over D. So you can work it backwards. So let's do some awesome proportion example problems. All right, so in this first one, I have 6 over x equals 21 over 31.5. So we're going to use, they call this actually means extremes, okay, or product theorem. So we're going to use that right now. And I'm going to get 21x is equal to 6 times 31.5, excuse me, which is 189, divided each side by 21. And my answer is 9. Okay. Problem B is a little bit tougher. So we may want to write that out. So we're going to multiply 5 times this equals 2 times 4x. And I would recommend you do this on your work. That way you don't make any mistakes. You know things are going to come out well for your algebra. So now we have to remember to distribute. We have to do both. So this would be 5x plus 15 equals 8x. So subtract 5x from each side. I got 15 is equal to 3x. Divide each side by 3. X equals 5. And you should plug it back in. 8 plus 3, well, 8 plus 3 is divided by 2 is 4. 4 times 5 is 20, divided by 5 is 4. So it's equal on both sides when I plug it back, this back in to my original equation. All right, why don't you try these on your own and hit pause, and then when you come back, we'll work on them together. Okay, well, hopefully you did pause the video right there and work these out. But if you didn't, I get it. So let's do this one here. I get negative 6x equals 44. Once we do our cross multiplication, right? This one we can just do in our head. So divide each side by negative 6, and I get 44 over negative 6. So that can be reduced. So since 2 goes into both of those, that would be negative 22 thirds, or negative 7 1/3, or if you use the calculator, negative 7.3 repeating. So if you're going to do that and use a calculator, you better make sure you put the correct notations in. Now let's do letter 3b up here. So I'm going to put this one first. So negative 4 times 2y plus 5 equals, well, 7 times 6, that's easy, that's 42. So negative 8y minus 20. Good with your signs, remember to distribute over everything in the parentheses, equals 42. I'm going to add 20 to each side, so I get negative 8y equals 62. Divide each side by negative 8, I get y is equal to negative 62 over 8. Well, those are both going to reduce by 2. So I've got that is equal to negative 31/4, or I can say that's 7 and negative 7 3/4, or negative 7.75. Okay, last problem here. So we'll go with 7 times z plus 4 equals 9 times z minus 1. So 7z plus 28 equals 9z minus 9. We'll subtract 7z from each side. So we end up with 28 equals 2z minus 9. I'm going to add 9 to each side. 37 equals 2z. Divide each side by 2, I got z is equal to 37 halves. I can leave it there. Or 16 1/2, or 16.5. Okay, Fernando conducted a survey of 50 students driving to school and found that 28 own cars. If 755 students drive to his school, predict the total number of students who own cars. So this is done all the time. Look, there goes my stock market notifications. And anyway, so the initial we're going to do is owners out of drivers, right? Owners to drivers. So 28 over 50 is equal to, now they say 755, drive to school, right? So it's, remember, owners over drivers. Okay. Brother, that looks terrible. I'll just keep it like that. Owners over drivers. So 755 down here, and then x up here. So we end up with 50x equals, and this is a calculator problem, 28 times 755, and you get 21,140 divided by 50. So x is equal to 422.8. Well, again, we can't have 0.8 of a human being. So we're going to say that we're going to round up to the nearest whole number, or down according, but we're going to round up to the ones place. So it's going to be that we would say approximately 423 owned cars. Okay. Want to do that because you can't, 422.8 people own cars, 0.8 of a person doesn't work. In an experiment, students netted butterflies, recorded the number with tags on their wings, and then released them. The students netted 48 butterflies, and 3 of those had tagged wings. Predict the number of butterflies that would have tagged wings out of 100 netted. Okay, go ahead and hit pause here, and you try this one on your own. Okay, well, thanks for having me back. So here we go. We're going to have 3 out of 48 equals x out of 100. Now, here's a little trick. There's 2 ways you could do this. You could cross multiply and divide. So we'll show you that method. 3 times 100 is, let's see, 48x equals 300. And we divide 300 divided by 48, and you get 6.25. All right, equals x. So we would say 6, right, is our answer. Let me show you another methodology here. Anytime we're looking out for something out of 100, that's called percent. So I don't have to go through all this method. I could just take 3 divided by 48. If you take your calculator and you go 3 divided by 48, what you're going to see is 0.06, 0.6, oops, 0.6, oh jeez. Come on, coach. Get it right. 0.0625. So that is what? 6.25%. So we want to round up again, round it down. So we would say what? 6% is 6 out of 100. So we'd still get the same answer. So you could do that if you notice this, asking for you get 100, you get this situation right there. Okay, let's highlight that with nice bright yellow right here. You get this situation right there. That's when you can use this here. Okay, equivalent proportions. Following proportions are equivalent. So if you flip them over, they're still equivalent because if you cross multiply, you get the same answers. Okay, so over here, no matter what, I would end up with AD is across from is on an angle like that from each other, and BC is as well. Same thing here, so B and C switch spots. Okay, we're still there. We're still there with this. Okay, so all of those end up with the same cross property, cross multiplication property. Hey, so you've got a homework assignment to do, and hopefully you do it, and pick up some neat knowledge about ratios and proportions. Talk to you soon. Be healthy. Bye.
That's all, folks.